flexing, extensive. Brand new Rari, Smith and Wesson.
So step one. So here what I'm gonna do, I have a torch, it's got damaged batteries. I've only got one battery, it's a 9-volt battery, so I haven't got a choice but to use it. It's the only battery I have. So what I'm gonna do is I'm gonna use a voltage divider to drop the voltage to 4.5 volts. As the 3 batteries all add up to 4.5 volts. So here I'm just drawing the circuit. So I have 2 resistors and a battery, and the top resistor is R1, the bottom one is R2, and then obviously the voltage divider is in between the two, so that's the V out. So what I could do is I could use a formula to give me the 4.5 volts I need. So V out is equal to Vn times R2 divided by R1 plus R2. So in this way, if I choose the same resistor values, so Vn is 9 volts, and then R2 and R1, they can be the same, 10k 10k, which will simplify it to a half, because obviously if you think about it, V out is equal to 9 times 10k divided by 20k, and then that cancels out to a half, which drops the voltage to half, which is perfect. So which is the same voltage I need to be able to use for the for the torch. I can't just use a 9-volt battery straight, because obviously it could damage the LEDs, because all LEDs have a limiting current. So obviously I can't exceed that, and in this case they've already calculated. So here I have 2 resistors. My 2 resistors, they're both 10k resistors. So I know they, like usually with certain resistors, you have to calculate how much power rating they can handle, because it's such a small voltage. So in this case it's not really necessary. So here I'm just connecting my battery clip to the voltage divider. So the top part I'm soldering now, that's where the voltage, that's the positive, that's the negative from the battery. So what I need to do is put a negative wire for the negative terminal for the voltage divider, and then obviously this is the one I'm soldering now, and then I need another wire, preferably red. It's easy to use colors that you're able to see so you don't get confused. So that's the middle part, so that represents the positive, that's the positive terminal. So regardless of what battery we put, the output is going to be half, but obviously it depends how much voltage you're going to put, because we're only dealing with 9 volts in this case. Our resistor are quarter power watts resistors, so they're able to handle that easily. So this voltage divider is quite useful because it's connected to a battery clip, so you could use it, clip it, unclip it if you need to. If I really need it to take it to the next level, I'll put battery clip. So here I'm just measuring the voltage to see if it matches the calculations, and you can see it's 4.2. That's because the battery is not, it doesn't have the maximum power, because obviously it's gone down. So what I'm gonna do here, I'm gonna disconnect the LEDs from the back. The other batteries, the 3 batteries, that resistor it limits the current for those, the other one for the thingy, and then that's the switch to switch from different options, different modes. So now what I'm going to do is I'm going to connect my voltage divider to the positive and negative end of the torch. The problem I had whilst doing this, I realized the battery, even though it's 4.5, it doesn't have enough power to actually drive the LEDs. So obviously it's Duracell batteries, I don't know, like yeah, I might need to use a better battery, but the voltage divider, it does show you it works, because I'm getting 4.5, which is half. But yeah, the battery is not as strong, so obviously that's another lesson that I've learned. Like the Duracell batteries, they don't deliver enough power. So what I then did was I just tried an experiment. You shouldn't try this, because obviously, so I just connected the 9-volt battery directly to the LEDs to try see what would happen. I was just curious, because obviously, and then I switched it on and wow, it worked. Nothing happened. The torch still works at 9 volts, which is a bit weird, but yeah.